Okay, so they are entering. Okay, so then looking at this right here, this is the people that's going to be entering. These are the people leaving. I just say exiting. And these are entering per hour. So then both EFT and LT are measured in people per hour, and the time is measured in hours after midnight. These functions are valid from 9 to 23, the hours during which the park is open. At time t equals 9, there are no people in the park. So looking at this part right here, when it says t is equal to 9, this kind of says to me that the park opens at 9. Actually, it shouldn't be 9 p.m. I guess 9 a.m. And in addition to that, I think that's about it. Another thing I noticed is that keep in mind that the rate times time passed is equal to the total value. All right, let's go ahead and take a look at the first part. So for A, it says how many people have entered the park by 5 p.m. or in this case, t equals 17. Round your answer to the nearest whole number. So looking at that right here, you're going to look at the integral from 9 to 17. And if you think about 17, that's really kind of equivalent. 17 minus 12 is going to give me 5 p.m. So 9 a.m. till 5 p.m. So you're looking at entering, so E of t dt, which is equal to 9 to 17. And you are going to insert this into your calculator. For week 13 Thursday, we went over how to use integration and derivatives on your calculator. So if you did not watch that video, that's kind of a really important part of it. You need to make sure you watch that so that way you know how to use your calculator on the calculator questions on the AP calculus test. So 15,600 t squared minus 24t plus 160 dt. So you're going to put this into your calculator. Remember, the function is just math, 9. Make sure you put 9 and then 17, and then make sure you put dx and then hit enter, but make sure you plug this into that. So if I were to plug this into into the calculator, I would do 15,600 divided by, put another parenthesis, x squared minus 24x plus 160, close, close, and then enter. So then once you insert that in there, it should be 6004.270 or approximately 6,004 people. The 0.27 is like a baby or something. So 6,004 people, and I oftentimes go back to the question and see what they're asking me. How many people enter the park by 5 p.m.? I would say this many people entered the park by 5 p.m. or t equals 17 since 9 a.m. That's what I would write. All right, let's take a look at the next one. For B, it's asking you the park admission is $15 until 5 p.m. or t equals 17. After 5 p.m., the admission is reduced to $11. How many dollars are collected from admission to the park on the given day? Round your answer to the nearest whole number. So we're going to do this based on 2 different integrals. The first one is going to be $15. That's going to be between 9 a.m. until 17 or 5 p.m. And with that one, you're still going to use the first equation because people are entering the park. So 15,600 t squared minus 24t plus 160. You're going to plug this into your calculator. And then plus your second integral, is going to include $11, which is going to be between the time of, I guess, in this case, 17 until the end, which is 23. And 23 is 11 p.m. Because if you do 23 minus 12, actually, it should be 12 p.m. or I should be say midnight. There we go. No, it would be 11. Just kidding. 11. Okay, and so that again, you will put 15,600 t squared minus 24t plus 160 dt on both. And then if you go ahead and plug this into your calculator, just remember this piece right here are people entering the park from 9 a.m. to 5 p.m. Your second equation is the count as the amount that you're going to be receiving as a profit from 5 p.m. to 11 p.m. And then when you plug this into your calculator, you should get a total of $104,048. Okay, for part C, it says let h of t equals this equation right here between 9 to 23. The value h of 17 to the nearest whole number is this. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17, the content of the amusement park. So with this one, your h of t is the integral of 9 to t entering, minusing, people leaving, dx, okay? Your h of 17 is equal to, starting at 9 o'clock in the morning, ending at 17 or 5 p.m., e of x minus L of x dx is equal to 3725. So this means 3,725 people are in the park at 5 p.m. since they open at 9 a.m. Now, the other side of this, h prime of t is the rate of change from 9 to t e to the x minus L of x dx. So then h prime of t is equal to e of t minus L of t. And so h prime of 17 will equal to e of 17 minus L of 17. And if you plug this into your calculator, literally just plugging in e of 17 minus L of 17, you will get a negative 380.281, which is the number of people in the park that is decreasing. So the rate of change of people in the park for number of people in the park is decreasing at the rate of 380 people per hour. So what that means is that by 5 p.m., people in the park are leaving. How fast are they leaving? 380 people per hour. And that is the difference between h of 17 and h prime of 17. Okay, very last one, which is D. At what time between 9 a.m. and midnight or 11 p.m. does the model predict the number of people in the park is at a maximum? So for this one, you will have to look at h prime of t as the first derivative, set it equal to 0, and you would need to find the critical point to test that. So h prime of t is equal to e of t minus L of t, set equal to 0. So this is a number of people in the park will keep growing until the rate of people leaving is higher then E of t, which is the number of people, or I should say the rate of people entering the park. So E of t is equal to L of t, and that time frame is going to be at 15.79. So that is approximately, if you do 15 minus 12, that's 3 p.m. And then in terms of 79, 0.79, convert that. This is so if you put this out of, let's say, 79 out of 100 equals to 60 out of whatever minutes it is, cross multiply this, which is going to give you the number of minutes, is equal to 79 times 60 divided by 100, which I don't have actually I do have a calculator. Let me see if I can find it on my calculator. Here we go. So 79 times 60 divided by 100. Okay, never mind. Maybe that's not going to work. That did not work as well as I hoped it would. Maybe 0.79. Okay, that's better. Actually, no, it doesn't. Okay, so never mind. I'm just gonna put it this way. I'm gonna take this off. So it's just gonna be approximately, you could say approximately, it's about 3:45 p.m. Actually, it's about like 3:47 is what it should be. 3:47. 0.79 over 100 equals minutes over 60 minutes. Cross multiply this. So your minutes is going to be 0.79 times 60 divided by 100, which is 47. So at approximately 3:47 p.m. is the maximum people in the park. After that, people are going to start leaving the park, and by 5 p.m. they reduce the emission rate. All right, you guys, so now that you have seen the answers, I would like you guys to go ahead and take a look at the grade of how it's going to be graded. So for this question, we're 3 points plus a 1 plus a 3 plus a 2. So altogether 9 points total. So pause the video and see, as a grader, this is what they're looking at, and see if you're able to match what we did to what they will be expected you to do to get a perfect score. All right, so once you're done with that, I want you guys to see some sample student responses. So here are 2 student responses on the actual test. Now, using the scoring guide, issue 9 points as if you are the AP grader. So this is a tiny URL you can use, or you can use a QR code. So let's go ahead and pull that up. Well, that's just odd. Give me 1 second. Let me see if I can redo this again. Okay, so once you get here, this is what it looks like. Here are the responses of the 2 students. This is how they responded to part A, part B, part C, and obviously this is very, very extensive, which is kind of nice. Part D, and then moving on to the next student for part A, part B, part C, and take a look at this and see how you would issue them a grade. All right, you guys, let's go back to this part then. The very last thing I want you guys to focus on is make sure that you guys are writing down the scores for the students. So this is student number 1, student number 2, and the very last part is going to be a quizzes for you guys that I want you guys to practice with. Since this week the topic is on derivatives, I'm going to have you guys go ahead and practice on the basic of derivatives. So let's go ahead, and you know what, I'm gonna have you guys, you could pick whichever one you want. You can just go over here and let's just look for one. No, I don't want the slide. Okay, let's do this one. Okay, so we're gonna go ahead and assign this. You guys have today to finish it, and then just go ahead and hit assign. So make sure you guys go to joinmyquiz.com, enter code 0656-1970. All right, let's go back to here. So just as a quick little reminder of what we're going to be doing today or this week, Unit 2 is due by week 13, which is this week, by Sunday by 11:59. Both Unit 1 and Unit 2 are done. If you need some additional assistance, these are the pages on your print and review book. Next week, we're going to start Unit 3, which is on differentiation techniques or derivative techniques. Read the books of 135 to 160. This is assigned for week 14, Monday and Tuesday. Pick any 30 questions. After that, we're moving on to Unit 4, applications of derivatives. And you can go ahead and do that for week 14, Wednesday, Thursday, Friday. Pick any 20 questions, so keep that in mind. And then again, this is due by week 14, Sunday, 11:59 p.m. So just keep that in mind. And then by week 15, we're going to finish up with concavity, and that'll be the end of Calculus 1. That you guys will take your AP practice test on that Thursday, Friday, and then we'll move on to semester 2 stuff right here. All right, you guys, I hope you have a wonderful week. As always, stay safe and healthy, and I'll see you guys next time. Take care.